This is the house in which I was born. Sorry for the interruption. This was the house in which I was born December 30th, 1921. It's a little two-room house. 1250 Fanny Avenue. It's 2 rooms. And in those days, of course, most children were born at home, as I was. The house was located at 1250 Fanny Avenue. The street was named for Fanny Hyde, one of Hyde's daughters. And its name was later changed to Greenwood. When I was born, my name was Bert LeRoy Colvin. Well, in 1925, I got a new dad and a new home. This is our home at 1403 South Kansas, across from Linwood Park. I show Linwood Park because I spent many happy days running around this park, climbing trees, and all the other things that boys do, playing baseball, football, any other things that a boy does in his youth. At 1403 Kansas, this is 1310 Ellis. I'm shooting this from the middle of Henry Park, which is right across the street. And of course, across Henry Park was the school I attended, Linwood. This was my grade school, attended from kindergarten through the 6th grade. Next to my grandfather's place, in 1946, my folks built this house, which I later bought in 1950, and lived here until. This is a picture of my mother, Gertrude McFarland, and my father, Bert LeRoy Colvin. They were married in March of 21. I was born in December of 21, and they were divorced a short time later. This is my stepfather, Jesse Boykin Clay, and my mother, Gertrude McFarland. His second marriage. This marriage lasted until my dad's death in May of 1960. They had a good marriage. Grandmother and grandfather, Florence Alpha Brantley and William Everett McFarland. My grandfather had a very strong influence on me when I was young. I mentioned my grandfather had considerable influence on me. For some strange reason, my grandmother lived down in Oklahoma. My grandfather lived a block from the school I was going to, and we lived 6 blocks from the school. So it was a habit of mine to go up there late in the evening, stay overnight with Granddad, and go to the school the next day, returning to my home over on Kansas, and then return to Granddad's later in the evening. Granddad was always taking me around to various and sundry aircraft plants. Now, I was only from the age of 6 to 8, I believe, in this time period when he was taking me around to the various plants. This particular picture is of the Rotable Airplane Manufacturing Company, which was established in 1925. I was only 4 years old, so I'm sure that I didn't actually visit this particular place, but there were about 25, 27 aircraft companies in the Wichita area, and an awful lot of them were located in that area from old Lincoln Street to old Central Avenue, and from Washington to just on the other side of the big river. And we went to many of these plants. And visited them. Also arranged for various field trips. This is a picture of my first grade class, and we're out at the airport. I believe this was probably Beach Field, and there is a transcontinental air transport Ford trimotor in the background. You can just barely discern it. I'm the only individual in this group that had a pilot's helmet. Granddad had bought me and my uncle, Bill McFarland, a set of these leather helmets, and we wore them almost all the time. This is a travel air plant located on East Central. There are 3 buildings. There was a 4th added to the east of the plant. We're looking east along Central Avenue. The road going off diagonally to the southwest there led to a little hangar that was the operating office of the Transcontinental Air Transport Group. As you can see, there's many airplanes on the field, and almost all of the early air shows occurred at this field, or air races stopped here to refuel. In fact, at this airport I saw my first parachute jump. I also saw my first parachutist killed. It's a woman. I later, after I'd got to the advanced age of 65, talked to the jumper that had ridden the opposite wing when her parachute failed. He made it safely to the ground, but he said it upset him so bad he didn't jump very much after that. As many of you know, the Travel Air Company was sold to Curtiss Wright in 1929, just before the Great Crash. Walter Beech apparently had foreseen the crash coming, and I believe the crash actually occurred on August 29th. You'll notice this is dated August 7th. But anyway, the aircraft business was really booming at that time. However, 2 years later, Travel Air was moved to the Curtiss Wright Company at St. Louis, and the Travel Air buildings stood abandoned for 3 to 4 years. In 1932, Beech came back to Wichita and started the design of the Model 17 in the old Cessna plant on Franklin Road, which has been changed to Pawnee. The Cessna East plant still is at that location. In late 1932, I had the luck of seeing the Model 17 make it either its first or second flight. It was a very impressive airplane at the time. Rather a brutish look. It had such a big engine in it, and had these big fixed pants that contributed a lot to the frontal area ahead of the CG of the airplane, which resulted in some instabilities. But it was a great airplane. This is the first airplane that I actually worked on. It's the Dow Special. It was designed by Wayne Dalrymple and Clarence Pfeiffer. These two gentlemen had approached the drafting class in Wichita East in 1937 to make drawings of this airplane, and I was one of the 5 people that worked on it, and I drew up the empennage and the landing gear and the engine installation. Johnny Wilson, as I recall, did the wing, Jack Green did the fuselage, and Freddie Klein, I believe, did all the flight controls and engine controls and instruments. Anyway, it was a great little airplane. Only had 37 horsepower. That's a little 2-cylinder Aeronica engine in it, and it achieved speeds in air races of 120 miles per hour, exceptionally fast for that much horsepower. This is a beach plant today. In the foreground you can see the 4 Quonset type hangars that existed in the old plant, a very small portion of the total area that is now Beech Aircraft. It's very interesting. The day that I went to work at Beechcraft, which was June 25th, 1940, there were only those 4 buildings existing. All of the rest of it has been added since then. Principally, the large section just to the south of the 4 buildings was added at the beginning of World War II, and that's where most of the production of the Model 18 occurred, and the Model 18 and the Model AT-10. The Model 17 was transferred to the old yellow cab hangar at the south end of the field on Kellogg and Webb Road. This is one of the first projects I worked on. I was actually employed to work in the tool crib in Department 26, which was a fuselage assembly. But I'd had some drafting experience, and when the engineering group had designed this ski installation, well, they had very meager information, and so as the parts were assembled to the airplane, why, I would have the job of making the drawing corrections and making all the changes in order to get the skis and their struts to fit. This project, we built 5 sets of these skis, fitted them to an airplane, made sure that they would work, and then boxed them up and shipped them to Canada or Alaska, wherever these were going to be used. The Model AT-11 is a derivative of the Model 18 used for bomber training, and this I transferred to engineering in 1942, and the first job they gave me was working on the retract system on this airplane, making new drag brace slide tube fittings, forging and the machine drawings. This is the XA-38, an attack bomber that Beech was engaged in the design. This airplane flew in middle of 1944. In 42, when I was working on it, while we were building the mock-up primary to be sure that the size of the airplane was correct, and then I was involved in the design of the flight controls, specifically the installation of the Sperry autopilot system. This was a hydraulic actuated system, no longer used in modern airplanes except for the heavy fighters and jet bombers. The airplane was unique in that it had a pair of turrets, one top, one bottom, and they were remotely controlled by a gun sight there in the canopy at the rear of the airplane, projected up through the top and bottom, and a single gunner controlled those guns. In the nose we had a 75 millimeter cannon with 16 rounds, and it had an automatic magazine. It would feed, load, and the pilot could fire individual shots in about one every 30 to 35 seconds. It was to be used for tank destroying, but the B-29 bomber, this airplane used the same engine as the B-29 bomber, and the engines were in short supply, and we were advancing on the Japanese at that time. Therefore, all the engine production was directed to B-29, and this project never got further than the 3 airplanes plus the static test unit. I've heard that there's one of these in a museum somewhere down in Florida, but I've never been able to get any contact on it. This shows kind of an interior shot of the airplane. Had a single pilot, a single gunner, and you can see the magazine for the 75 millimeter cannon just ahead of the cockpit section, and the dual turrets. They're all fuel tanks in the fuselage and what would normally be the bomb bay, and the wings were full of fuel, but it carried its bombs externally on the wings. Had a lot of radio gear in the racks in the aft side of the airplane. This is a Dimax in the house. This was an idea that Beech thought they might build after the war, and they actually built one unit, and which was located at 1960 Easy Street. Can't remember the man's name that owned it. You can see the Dimaxon section in the background, and then he built some additional housing to add to it. The house was very unique, and that it was all aluminum. It was built on a single post with the idea that the house could be rotated so that any room could enjoy the benefits of the breeze or the sunshine, depending on which was deemed the most desirable at the time. Of course, air conditioning, I think, killed that feature. Beech also designed an automobile. This automobile was unique in that it had an engine that drove generators, which supplied power to motors in each wheel. It had a 4-wheel drive. They say it had excellent acceleration. Unfortunate part about it, though, it was very, very expensive. But it's kind of an indication of some of the projects that they were considering after the war. I spent my time in the Marine Corps from June of 1944 until August of 1946, at which time I returned to Beech Aircraft. and worked on the Model 34. This is the Model AT-10 modified with a V-tail. Ralph Harmon had discovered an article about this V-tail on a Russian, it was installed on a Russian airplane, and he was rather impressed with the idea that you could reduce the total drag associated with the airplane. For some reason you had smaller tail surfaces and only two intersections creating drag on the aft fuselage. The company, he was able to sell the company on building at least a test prototype. In fact, the company took the idea to the Navy, and the Navy actually furnished the money for the research associated with this tail. The tail, of course, was incorporated on the Bonanza, the now famous Bonanza. This airplane was designed by Ralph Harmon, and was unique in that we built two entirely different wings. One a very low drag airfoil, NASA low drag airfoil, and the old NACA 23,000 series. And the 23,000 series had better stall characteristics and better landing characteristics, therefore we stuck with the 23,000 series. I didn't get a chance to work on this airplane. It actually flew in '46, just about the time that I got back, and then was certified in 1947. I spent my time at that time working on what was called the Model 34 twin quad, Beech Model 34. This was a 4-engine airplane, had two engines driving a single prop on each side. I did a lot of design work on the hydraulic system on this airplane, and also in the flap control system. I designed a flap drive actuator, which later was used on the Model 50, the twin Bonanza, as a landing gear retract actuator. So it lived on. This is the interior of the airplane. It's 3 abreast, carried 26 people, and it was rather unique in that it incorporated baggage lockers. There was no such thing at that time, and Beech had proposed this idea, and we actually designed and built the suitcases that went in these little baggage lockers. The suitcase was rather special. It was about 18 inches long, a little bit smaller than the normal suitcase, but it was a very, very fine piece of equipment and a fine idea. Later been incorporated into the later jet transports. This is a view of the airplane looking forward. There was 3 seats on each side that comprised possibly an auxiliary cargo compartment. There was a 6-foot cargo compartment between that door and the cockpit. You can see the sill of the cockpit. That's the dark background through the doorway there. And so you had that 6 feet, and then by converting, the chairs actually would fold up and lock into the ceiling, and then you could again have space for the additional cargo as shown here. It was rather a unique, quick change approach. The airplane was deemed unsuccessful in that the market, there were so many DC-3s on the market that there was really no market for this airplane, because this airplane would have cost $250,000, where the DC-3s could be picked up from anywhere from $10,000 to $30,000 surplus. This shows the engine and propeller drive arrangement on that airplane. As you can see, there were 2 8-cylinder Lycoming engines buried in the wing. I had leading edge inlets for cooling, and you can see the cooling discharge elements on the top of the wing to the rear. They drove into a common gear drive, which of course changed direction also through some clutches, and to another reduction gearbox in the front side. This was unique in that if you lost an engine, well, of course the engine could be shut down, but the propeller continued to drive. Due to the lower disc loading that occurred because there wasn't much horsepower, the actual thrust capability of the propeller efficiency improved, and therefore you didn't really lose 1/4 of your thrust. You actually lost just maybe 70% of that thrust, which give you a much better performance. This is a very special Bonanza that was built using some of the same ideas that were used on Model 34. This was our Model 40, and it was actually a twin engine airplane. Here's the engine that had two 4-cylinder Lycoming engines of 125 horsepower each, going through a gearbox, again with clutches and so forth, so that one engine could be decoupled in case of an engine failure. The airplane again was discontinued because of the depression that occurred in the aircraft industry in about 1949. Sales dropped drastically and everything shut down, almost as bad as the depression of 1932. The company had embarked on, though, a model of a modification of the Bonanza, which was our Model 45. The Bonanza was Model 35, and this happened to be in the design sequence, the Model 45. Used the Bonanza engine installation, wing, aft fuselage, and turned the tails flat for the horizontal, and modified with a leading edge extension another one of the Model 35 surfaces, and used it for the vertical stabilizer and rudder. This was a two-place canopy. It was unique in that both canopy sections would open. They would also jettison. And this was the first airplane that I had a fairly large responsibility for design of a complete section. I had the complete canopy structural design from a line that's about 5 inches below the shiny part of the canopy to the top of the canopy, and running from the firewall, which is about 8 inches ahead of the leading edge of the canopy, to about 12 inches behind the canopy, the aft canopy. And all that was designed and built as one chunk, and then just set down on rails that formed the upper longerons and fuselage, and riveted to it, and that was our total support structure for the canopy. Very nice airplane. We sold to both the Air Force, to the Navy, and the airplane was later modified into a turboprop powered job, and was sold to the Navy as a T-34C, and it's still in use and training today. This is a twin Bonanza. It was called that primarily because we used the canopy, the model, the Bonanza canopy, split it and put a 12-inch section in the center of it, and then designed the rest of the airplane around it. This particular airplane, I had the responsibility for the design of the fuselage from just after the propellers to back behind the baggage door. It was fairly conventional structural, but I also had to put in the seats and the flight controls. This is when a fairly small group of people were involved in the total design of the airplane. I believe there were 8 of us involved in this. And of course, there was an engine man, there's a landing gear man, there's a flight controls man, and then there were 3 fuselage structures people, one for the aft section, one for the nose section and myself for the center section. There was a wing center section and an empennage man, and I think that was just about it. We had plus we had a structural man that was guiding us in all the loads, derivation, and so forth. But anyway, this was a kind of a high-speed program in that we started on it in May and flew it in November and certified it, I think, some like the May of the next year. Our next major design project was what was called a T-36A. This was a large twin-engine airplane powered by R2800 engines, 2,000 horsepower each, full feathering propellers. It was unique in that it carried 12 people in the rear. Plus, it had a very large canopy which seated a pilot, co-pilot, and 2 trainees. In other words, its primary mission was training, but it also was used for cargo. Hauling had a fairly large cargo door on it, and could also be used to haul personnel. This project started in 1951 and proceeded. These are some pictures of the cabin mock-up, showing the interior of the cabin, the cockpit. The airplane as it's set on the ground. There's a view from the rear and a view from the 3/4 front. The contract was canceled in 1953, August, and primarily because the Air Force had made a major decision that all aircraft that they were going to buy would be powered using JP4 or kerosene, which did make the Air Force totally jet powered, and so we tried to get the airplane modified and hang a pair of jets on it so we could continue with the program, but unfortunately there weren't any jets at that particular time that really would power the airplane. Most of them were too large, and the engines that were on the B-47 and the B-52 were quite a bit larger than needed to power this, and there wasn't time. It would have meant the development of a new lower powered jet in order to make this airplane a success. Anyway, we were unable to turn the military around, so we proceeded with other projects. This is a study project. The military had a very long-range bomber, B-36. It had about an 8,000-mile range, which was way beyond the escort capability of the fighters. Well, the Air Force was looking at many ways to carry a fighter along, and you see there was a McDonnell Goblin, which was a small airplane that was carried in the B-29 fuselage bay, bomber bay. Also, they had another approach that used a big hook to carry an F-84 underneath the B-36. This was a proof of concept idea. It had 2 major features. Number one is that if you could extend the wingspan, in other words, the span loading of the airplane was decreased, and therefore the airplane could fly a lot further on the same amount of fuel. So the idea was that if you could couple a pair of fighters to each wing, and then the fighters could be on there until, of course, they had to jump off in order to defend the airplane, but at least they would be able to carry along. They didn't waste any fuel. They could be fully fueled when they took off, and the airplane therefore had long range and had fighter escort. We actually flew this airplane and did quite a bit of testing, proved the concept, same time, the jet bomber, particularly the B-52, was exhibiting enough speed capability that a lot of people felt that there wasn't really any need for this type of fighter defense. And almost all bomber attempts or bomber programs have proceeded with this idea. They've carried no fighter defense at all. They've had their own internal defense and used either low-level altitude to keep them under the radar ranges and high speed to avoid detection and being killed by the enemy. Anyway, it's a very interesting program. We also were looking at a turboprop. There was a turboprop engine being developed, and we submitted designs for a turboprop trainer, which the turbine was mounted behind the cockpit. It was fed air through those side ducts, and then a long shaft running under the pilot's floor drove the propeller in the front end. At the same time, a gentleman by the name of Herb Dickard had been looking at the idea of using two Marbury. They were, I believe, 750-pound thrust engines. And he conceived this little airplane with the idea of being a better airplane because it had twin engine reliability and so forth. And also there were some elements in the military that wanted a side-by-side cockpit. So as part of our presentation to the military at that time, why we said, yeah, we could build you the turboprop, but here's what we think will really do you a better job. Well, the military was really entranced with the idea. They rewrote the spec around our airplane and offered to give us a contract. Unfortunately, this was in April of 1953. We were real deep in the T-36 program. Nobody envisioned that program would be canceled. And therefore we had to, Ted Wells wrote the letter, told the military we were very sorry that we just had too much to handle and that we would have to turn down this concept. But he did mention that we had an aircraft company across the town that was very, very capable of building this size of an airplane. And lo and behold, Cessna entered the program and won the contract. We were glad to see them do it. Unfortunately, we had been fighting them tooth and nail if we didn't have the T-36, if we had known the T-36 was going to be canceled. This shows an interior view of the airplane with its two engines, side-by-side pilots. And we had a rather unique construction. Of course, sandwich construction was coming into play at that time. And what this had the unique ability to allow us to build a structure that could be retained to the aft fuselage with just 4 bolts. And that way, by removing these 4 bolts and having a dolly, you could truck the whole fuselage aft, and then you'd have complete access to the engines. The Cessna design actually buried their engines in the wing root, and they had a terrible maintenance problem. We think this would have been a better solution, but that's hindsight. We looked at other things. Of course, the big buzzword at the time, this is in the 1953 to 56 area, was VSTOL. The military was looking at all kinds of configurations that would provide low-speed takeoff and landing, and they wanted an airplane. In this particular case, they were wanting a cargo hauler. And so we had developed some wind tunnel models and got the military interested enough that we pursued the idea with, again, though, our big problem was that we didn't have any turbine engines that small. they wanted about a 26,000 pound small cargo carrier. This was a triplane, and the whole concept was that it was flapped in such a manner that the three wings formed a cascade, so that you had a large area in the flap condition that would turn the slipstream from the propellers down, and therefore provide a vertical component that would provide high lift. And we did actually, in Bonanza, develop lift coefficients of 04 or slightly over, which is about twice what you could do normally. But again, the power plant situation kind of brought the airplane to an end. At the same time, looking for ways to increase the sales of the Model 18, which was basically it, and the Bonanza were our only product at the time. Why we did the Super 18, which was a 8-inch raise in the cabin top, which therefore improved the entry, traveling up and down the aisle, made the seats seem more comfortable, give you a lot more headroom. You didn't feel like you're crowded, and was very popular at the time. They sold several thousand of these airplanes, and this particular one we also modified it to have a tricycle landing gear on it, which of course after the war, why tricycle landing gear was the only way to go. This is what became known as a travel air. It was really what the twin Bonanza should have been. This little airplane used basically a Bonanza wings. We hung a pair of small 180 horsepower Lycoming engines on those wings, no increase in center section. Again, used the tail off of the Model 45, or the T-34 A or B, and then we put a 36-inch extension on each wingtip to increase the span. Made a very nice little airplane. Probably the first twin that I ever flew, and I made several trips in it. It was a marvelous little airplane. But it was replaced later by the Baron, which had more horsepower and was a much faster airplane. During the same period, there was still a need for the jet trainer. The Navy was very interested. They didn't buy the side-by-side concept that the Army was entranced with, and they put out a spec for a small two-place trainer with ejection seats to be jet powered. And so we built this airplane with the Marbury. It had a single Marbury engine. Idea being that we could produce an airplane at about 3/4 of the cost of the Cessna T-37. Anyway, it was a very nice airplane. The contract, though, was won by TEPCO, but they only built 16 airplanes, therefore Beech really gained by not winning the contract. This was a very nice airplane. We also entered into an agreement with the French on a little 4-place jet. It unfortunately was not pressurized, therefore flight altitudes were limited to below 25,000 feet, and you had to suck on oxygen all the time. It was a very nice airplane. It had very good handling characteristics, but it was very limited on range. Had about a 500-mile IFR range, which he'd spark right along at 400 miles an hour, and was a joy to fly. We spent quite a bit of time looking at various jet configurations. Each aircraft probably didn't have the capability to produce this. North American actually won the contract, which ended up in the North American Sabre. This was one of our twin-engine versions. We looked at many, trying to get the ideal. This was a 3-engine version that we looked at, Um, the military actually had two requirements, one for a twin-engine airplane and one for a multi-engine airplane. They wanted better performance, and so we looked at this 3-engine version and of course 4-engine versions. The 4-engine version that the military bought was the Lockheed Jetstar. We were also looking at ducted fans. We had many different type of configurations. This was an arrangement with ducted pushers. We also spent quite a little bit of time looking at rotable airplanes. This particular airplane was designed with the idea that you could just come along and disconnect the fuselage, take off and drive around town, come back and hook her up to the airplane and take her off again. About 1958, the twin Bonanza was losing disfavor with the public, and they wanted a bigger cabin, wanted an air stair door. We made a lot of modifications to the twin Bonanza that finally decided to put a new fuselage on it. And this was the result of Queen Air Model 65. Used the twin Bonanza empennage, wing, engine installation, but did put a nice fuselage on it. This fuselage, through extensions, increased length, and pressurization, became a fuselage for the King Air and the King Air 100, 200, 300, and even the basic shape is a cross section for the 1900. These are some studies of some transports that we made. They range from 4-engine reciprocating to 2-engine turboprops. We even had a 3-engine turboprop. One of them has pusher in the tail, mounted in a configuration that Boeing has used in their 737 design. And then we had 2 large turboprop engines as pushers in the tail. There were quite a few advantages to the pusher. We thought there'd be lower noise, and you'd have all that propeller behind the passengers, so forth. But we pursued the idea, but never actually built any hardware. These are some design studies that we made leading up to the Musketeer or Sierra. We looked at all kind of configurations. You notice there's the pushers, we had B-tails, we had standard configurations. We even had a canard in the picture. But the conventional configuration won out as being the best performance at lowest cost. And this was the airplane that was finally built, 4-place airplane. Had unique rubber shock absorbers, very low cost airplane. This was a project that I was associated with. I was in preliminary design after coming back from the North American plant, where I was the beach representative on the B-70. And I got back into preliminary design, and the company kept a design goal. They wanted an airplane that would carry 8 to 10 people, travel 325 miles an hour at 25,000 feet. Well, there was an engine being developed by the French, a Turbomeca Baston engine, and I did some analytical work and developed a 3D for this airplane and presented it to the company, and the company gave me a go-ahead to build a full-size mock-up. They wanted to see how the airplane looked in all aspects. So we built this full-size mock-up, which is as close to a real airplane as you could possibly get. Here's the interior of the airplane. It was plush. The color work, the artist did an excellent job on this, and artistry, the color schemes, the ideas, the layout were later used in our stretched version of the King Air, and was a big hit with the customers. At the same time, I was working on this airplane, on the Model 120. We were working on this airplane in preliminary design. We had started working on it even before I started on the 120. It was the NU-8F. It was merely a Queen Air Model 80, an unpressurized airplane that was going to be powered by a new 400 horsepower Pratt & Whitney turboprop. This is the first small turboprop that was being developed in the country. We, meaning Pratt & Whitney and Beechcraft, joined forces in the design of this airplane, build it, and then give it to the military for $1 as a demonstrator. Well, it excited the military. Of course, it had some things wrong with it. Number one was the engine horsepower was too light, too small, and so they approached the Pratt & Whitney people about bumping the horsepower to 550 horses, and approached us about a configuration that would meet some short takeoff characteristics. We modified the airplane and ended up selling about 250 of these to the military as the L-23, I can't remember that designation. From that airplane, though, we had a program where we were pressurizing a Queen Air. So we had a pressurized fuselage, and still had the old reciprocating engines on it. It's going to be called the Model 88. Well, Mr. Hedrick took a ride in the NU-8F with the turbine engines on it and was so impressed with the quietness of the interior of that airplane with those turbine engines on it that on landing he told him to drop the program known as the Model 88 and put these Pratt & Whitney engines on this airplane. So we did, and this is what became the King Air. It was certified in November of 1964 and generated a great number of sales. Another one of our projects was associated with some of the spook programs that the military had. They wanted a fly-in relay station, so we designed this airplane to be radio controlled, and it was to take off and climb to 30,000 feet. It had to provide stabilized power, so the big bump on the nose there houses a belt-driven alternator that provided regulated 400 cycle power to all the electronics equipment that was carried in the back end. And we had to maintain on-time station up there for 8 hours, and then it would return home. It was fully radio controlled, could be guided by a pilot on the ground. He using radar to guide the airplane to the spot where it would orbit and relay information back from the enemy. This was a program in which they were trying to generate all the information on the enemy's movements, where their gun positions and so forth. And never did know how it did its job, but we sold about 35 of them. This was my next big project. In 1969, Roy McGregor was the vice president of marketing, come to me with the idea. He says, I need an airplane that will meet the company's 325 miles an hour at 25,000 feet, but will also carry a big payload, so it would have to weigh about 15,000 pounds, have to be structurally sufficient to carry 15,000 pounds. Also have the the horsepower to meet the takeoff and landing requirements and so forth. And so I, using the basic King Air, stretched it a bit, stretched the center section some 50 inches, moving the engines out 25 inches, added another 2.5 foot to each side of the wing, increasing the span to about 54 feet, and added a new T-tail to overcome some of the controllability problems that we had encountered on trying to increase horsepower in the basic Model 100. We also increased the pressure in this to 6 psi, so it would maintain an 8,000 foot cabin up to about 29,000 feet, giving us a little better altitude performance. In fact, we actually certified the airplane to 30,000 feet, giving us a little better altitude performance than had originally been planned. The next step was to try to put a jet engine on this airplane. Unfortunately, the airplane was low Mach number limited. In other words, the wing sections were too thick and wrong shape to take advantage of the jet engine. But we got a lot of experience with the jet engine. This is JT-15D engine, which now powers the Beechjet, which is a later derivation. We also looked at, because the T-tail was made so popular on the Model 200, why we started putting it on all our airplanes. This was a Bonanza. We were looking at a pressurized Bonanza. We actually developed a pressurized Baron, and we then took that fuselage, put it back on a Bonanza with a bigger power plant with a turbocharger on it and a T-tail. We were going to have a pressurized Bonanza, but the cost projections indicated it was really too much for a single engine airplane. We later carried the same idea to a turboprop. This airplane was powered with a Garrett air research engine and provided very good speed. It was an excellent program, but again, it was going to cost $1 million a copy, and therefore they didn't think it would generate too many sales for a single engine airplane. We kept looking at various combinations that we could use to increase the capability of the basic King Air. The company wanted a turboprop that would do 350 knots on approximately 400 miles an hour at 35,000 feet. They wanted a turboprop. It would have been much easier to accomplish it with a jet, but there was a great cry from the marketing people that our turboprops had been so successful, and we wanted to keep under the 12,500 pound Par 23 design limit for reasons of building lower cost airplane. Therefore, we were looking at various ways. This is a wind tunnel model of one with a very large engine. The fuselage was lengthened by putting the pilots ahead of the propellers, so we gained some additional cabin space, again using the T-tail of the present airplane, and had an all-new wing on it. Larger in area, I think it had about 350 square feet, about a 60-foot span. Anyway, we also looked at many other configurations. This is a picture of the Lear fan. This, of course, is a configuration that we looked at a long time ago in the Model 34 and the Model 40. But we wanted to look at it again because the poop on the Lear fan was that it was make an excellent airplane. It was very fast, it was sleek, it was small, and it really slipped through the air. And they said it was very quiet. So we investigated this configuration at great length. One of the methods was to still keep the engines in the fuselage, but drive two propellers The reason for this was that our big problem with the single propeller back there is that the FAA would not allow us to consider it a twin-engine airplane. They said if there's an engine failure, it becomes a glider, and therefore it cannot possibly be considered a twin-engine airplane. And if it loses an engine, that's all right. Then it remains a flying airplane. If it loses a propeller, it's all charoo. So we looked at many configurations trying to get around that. Here's another one in which the engines were mounted at the side and drove a straight shaft back with the V tails mounted off of that. We also hired Bert Rutan to look at some configurations. Our in-house, we had become convinced that a configuration fairly simple, similar to the number 3 that Bert Rutan proposed. In other words, it's called a 3-surface configuration, offered the greatest possibility of developing the fastest configuration. All of our studies indicated that that's the way we should go. And in other words, it was about 50 miles an hour or 35 knots faster than any of the other configurations. However, the management saw it a little bit different in that Piaggio was already building a 3-surface configuration, and they wanted something unique. And so the Starship configuration is shown here with Model 17 was adopted by the company for development. To sum up my career at Beech Aircraft, I started in the tool crib, worked up my way to crew chief on the Model 18 tail jigs, transferred to engineering, worked on several of the design concepts in engineering, joined the Marine Corps in June of '44, come out in August of '46, and rejoined Beech Aircraft and stayed there for the rest of my career. I was involved in the design of almost all of our new airplanes during that period, in some portion of the design of them. And in 1965, I became chief of systems design. Systems design was a new organization set up that would have responsibility for power plant design, flight control design, interior design of the airplane, all the mechanical systems, and all of the environmental systems, electrical, electronics, so forth. I was head of this group for almost 2 years until 1967, when I returned to preliminary design as chief of preliminary design, where I worked on many of the preliminary designs that we had under investigation until 1971, when I was appointed project engineer on the Model 200. The Model 200 had a great controversy within the plant. There were many people, primary marketing, and some of the manufacturing people, that were dead set against us generating a new turboprop airplane. And therefore, Mr. Hedrick had assigned my boss, Mr. James Liu, Vice President of Engineering, and Roy McGregor, Vice President of Marketing, as the 2 chiefs to run this program, of which I was their chief deputy as the project engineer on the program. Well, the program turned out so successful, we were able to sell about 1,500 of them to the commercial fleet, right off the bat. It was gaining a high production rate because everybody wanted it. It fulfilled all the requirements and give the pilots an airplane that they felt perfectly safe in handling. and we developed a cargo door for it. We also developed a 1900 out of it, and it also won the competitions for the Air Force Army airplanes. We later then sold it to the Navy and also to the Coast Guard, the Marines. It was the only airplane in the U.S. inventory that was used by all 5 services. So it turned in, anyway, after that, after developing the Model 200, I was brought back in as manager of advanced design, and then became head of research and development in 1978, and carried all the development program in the 1900 and its series of airplanes, and did all the preliminary design work on the airplanes leading up to the Starship. Became vice president of engineering in February 1984, and retired in June 30th of 1985 after completing 45 years of service of each aircraft. Since retiring, I'm just primarily a volunteer.